Next in geometry is mathematical system operations with sets. But first, let's review a little bit. The set of lessons in this geometry course is finite or infinite? Finite, because remember, you can count it. The set of counting numbers, is that finite or infinite? Infinite, because numbers just keep going on and on and on. You can't count them. What about the number of students in this class? Is that finite or infinite? Finite. Okay. What is correct set notation? Okay, make sure you remember that correct set notation has brackets around it, and all the elements inside of it have commas after it. It doesn't have to be 1, 2, and 3, but whatever you put have to have commas after them. Okay? If these are parentheses, that's not correct set notation. If there's no brackets here, that's not correct set notation. It has to look like this. Alright? What does this mean? Eight is an element of R. Well, what does this mean? Eight is not an element of R. Okay, I want you to tell me if this is a finite set or an infinite set. All the whole numbers. Infinite. All natural numbers less than 100,000. Finite. All letters of the alphabet. Finite. All the odd numbers. Infinite. The world's population. Finite. Even though it's a huge number, you can still count it. What about the empty set? Finite. True or false? The empty set, or null set, is a subset of every set. True. The subset 3 is a subset of 1, 2, 4, 5, and 6. True or false? The set 3 is a subset of the set 1, 2, 4, 5, and 6. False. There's no 3 in that set. If I said, I want you to make a set of all the even numbers between 2 and 10 inclusive, what would my set be? Okay. I said I want all the even numbers between 2 and 10 inclusive. Inclusive means I include 2 and 10. Okay? So you should have 2, 4, 6, 8, 10. Okay? Alright. The empty set, true or false? The empty set is a subset of the set 1, 2, 3, 4, 5, 6. True. Remember, the empty set is a subset of every set. What does this mean? 4 is an element of X. Okay, is this a finite set or an infinite set? The set of lessons in this course, that's finite. The set of even numbers from 0 to 1,000,000, it's finite. 10 billion, finite. The set of integers, that's infinite. The null set, that's finite. The set of counting numbers, that's infinite. The null set, that's finite. How many subsets can you create from this set 1, 2, 3? Well, we have the set, this is a subset 1, 2, 3. Changing the numbers around doesn't matter. It doesn't matter what order they're in. Okay, first of all, we have the empty set. Then we can do a set with 1, a set with 2, and a set with 3. Okay, so we listed all the ones with 1 number. Now let's do the ones with 2 numbers. We can do 1, 2, 1, 3, and 2, 3. Okay, and that's all of them. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 subsets of that set. The set is also the first subset that you write down. Okay? Alright. Is the set 4, 5, 6 a subset of the set 4, 5, 6? Yes or no? Yes, it is. What are 2 ways to describe the set of all letters of the alphabet? Okay, we could go A, comma, B, comma, C, dot, 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 Z. Or we could do the rule method, letters of alphabet. I know my marker's dying. Okay, so there's the list method and the rule method. Alright, here we go. What does this mean? Alright, here we go. What does this mean? A is a subset of B. Alright. Just a minute. Archimedes is known for what? 2 things. The classic method of computing pi and developing the seed ideas used for integral calculus. True or false? Thales is credited with the statement, the diameter of a circle bisects the circle. True. True or false? Euclid is known for his book called Elements. True. True or false? Euclid is known for using deductive logic. True. True or false? Euclid is known for using axioms and definitions. True. A minute. Who is credited with being the first to make logic into an abstract form? Aristotle. Who is credited for developing the classic method for computing the number pi? Archimedes. True or false? The ancient civilizations of Greece, Egypt, and Babylon all had some estimate of the number pi. True. The two mathematicians who developed integral calculus, Newton and Leibniz. Okay, if you had any problems on any of that, I want you to stop the tape, and I want you to go back, and I want you to study it until you know it before you do the next lesson. Okay? Our lesson today is called Mathematical System Operations with Sets. Our goals for this lesson are to find the intersections and unions of sets, set operations, and to solve word problems using set theory and set operations. Okay, the union of two sets is a third set consisting of all the distinct elements of both sets. We talked about that last time. Unions of sets can informally be thought of as a sharing situation. Suppose two boys are building a tree house. Paul has a perfect tree in his yard and a good hammer. Tim has access to a lot of scrap lumber that his dad will let him use, and he has nails and a saw. So P equals tree and hammer, T equals wood, nails, and saw. The symbol U, remember the word union starts with U, union. Thus, Paul union, or P union T, Paul union Tim, is all of it. The tree, hammer, wood, nails, and saw. By including all the resources of Paul and Tim, we have a third set which can be used for building the tree house. Okay? And so if I have, go ahead and skip a space in your notes and write today's dates. And today we're going to talk about operations with sets. Operations with sets. You can write those words out if you want. If you don't feel like abbreviating, that's fine. We said if A equals the set 1, 2, 3, and 4, and B equals the set 3, 4, 5, and 6, then A union B equals the set 1, 2. Now look, there's 2 3s, but I only write it once. 4, 5, 6. Now, no matter how many times they're listed in this set, I only write the element once. Okay? Now, what if I wanted, do you remember what this symbol means? This is an end. Think of intersection. So I only want the elements that are in both sets. Okay? Which would be 3 and 4 are the only two that are in both sets. Okay? Alright. A lot of times when we do sets, your lesson uses pictures to display the sets. So how we would display this Okay, let me erase this. How we would show this, it draws a rectangle. Man, seriously? My markers want to quit on me today. Okay, let's do this again. Okay, there's my rectangle. Okay, for A union or intersection B equals C, it would look like this. We'd have a Venn diagram. A, B, and this part in the middle is C, and this is where they intersect. Okay? If A intersection B equals the empty set, that means they don't overlap. So we don't have that gap. So we have A, B. We have two disjoint sets. Okay, we don't have the intersection right there. Okay, now if we have A intersection B equals B, what do you think this is going to look like? This is going to be A, and this is going to be B. I'm sorry, A goes in here. My mistake. Okay. Because B is the intersection. Alright. Sets that share no common elements are called disjoint sets. Those are disjoint sets. Whenever a set such as B contains only elements that are also elements of another set, the set B is called the subset of A, like this one. If two sets are equal, then they are subsets of each other. Alright. We talked about this yesterday, but just so you know. If two sets are equal, that means they're subsets of each other. Do you remember how to write it? We wrote it like that. It means they're subsets of each other. Okay. In a Venn diagram, the complement of a set consists of the elements that are not in the set. Okay. The complement of any set X is represented by X with a line over it. In the model below, subset B is a collection of odd numbers. Okay. Now we have a set. Whenever you have a line over it, this means the is it an I or an E? Complement. It's an E. Complement of X. Complement means opposite of. So it's anything that's not in the set. Okay. So if I have my rectangle, and this is hard because my markers are running out of ink, but if I have a set here, alright, and I have 2, 4, 6, 5, 1, 3, the B, it has a comma, an apostrophe after it, and I have this circled, okay. In the model below, subset B is a collection of all odd numbers. The complement of odd numbers would be the even numbers. Remember, by rule, the empty set belongs to each subset. It is the intersection of these disjoint sets. The empty set is also a finite set because we can count it. So the complement is the opposite of. Okay? Alright. I guess there are vocabulary words here. Okay, let's look at our vocabulary words. I'm going to say a definition and then say the word. I want you to repeat the word after me. Sets that have no common elements whose intersection is the empty set are disjoint sets. The elements in the universe, okay, this square is called the universe. I don't know if we said that or not. Or a rectangle, I mean, whatever's in there, it's called the universe. Okay, sorry. Where was I? The elements in the universe that are not in the set is the complement of the set. A set containing elements in common for all sets being considered is the intersection of sets. A set that contains only elements found in another set is a subset. A subset that does not contain every element in another set is a proper subset. A set containing all elements of all sets being considered is the union of sets. Okay. Let me look and see if there's anything that I didn't say. No, there's not. Alright. I want you to go back and study your notes. Make sure you understand it and go ahead and finish these questions.